Intel was once the biggest CPU maker in the world, and certainly the biggest desktop CPU maker, but now? Well, now they're struggling, and are at a point where without significant changes, they're heading for a straight repeat of AMD in 2012 through 2018. In other words, Intel is now a sinking ship, and it needs to turn course quickly, but with a boat this large, often struggles to make such rapid maneuvers. But to best understand how they got here, we need to take at least a brief look back at Intel's history and the path that led them here. This is the story of Intel's possibly imminent collapse. Intel has been around for a long time. Founded in 1968 by two of the traitorous eight who left Shockley to found Fairchild, who then left to found Intel. Those being Gordon E. Moore, the Moore's Law guy, Robert Noyce, and Arthur Rock. I've already covered a lot of Intel's early history in another video you can check out up here, so suffice to say that they started small and worked their way up, going from a couple hundred, couple thousand transistor CPUs to millions. Let's pick up after the introduction of their x86 CPUs, like the 8086, 8286, and 8386. This is where Intel first got some real competition, but not from where you might think. Back in those days, companies who were buying Intel CPUs, like IBM for the IBM PC, required Intel to offer a second source manufacturer for their products. So if Intel couldn't provide enough units or just a second source was available, their second source could. AMD was one of those second sourcers, making their own version of basically all of Intel's CPUs at the request of Intel. By the 286 and 386 days though, Intel was getting tired of essentially just splitting profits of their own designs with people like AMD, so started cutting second sourcers out. AMD, among others, spent a lot of time reverse engineering Intel's chips and designing their own, often slightly better versions. Intel's first big anti-competitive move was using, copywriting, and enforcing legal action on microcode inside their CPUs. That's what we would probably just call firmware today. While even the original 8086 had some microcode, the 486 and later P6 Pentium Pros expanded the use of microcode pretty significantly, and because software is copyrightable but hardware isn't, Intel could sue competitors like AMD and NEC for using Intel's microcode. The NEC case is actually what decided that microcode was software and therefore was copyrightable, despite NEC being able to prove that they wholly reverse engineered the chips and did not use Intel's own microcode, instead using clean room principles to recreate them. The result of all of that though is that Intel walked away with $40 million from AMD in 1995, although AMD was allowed to keep making reverse-engineered versions of Intel's chips. Ironically enough, AMD's own foundries were actually ahead on the process node front, allowing them to offer a die-shrunk version of the 486, the DX4, that was actually faster than Intel's much newer early Pentium chips. But Intel still held the lion's share of the market. Other competitors like Cyrix came and went, with only AMD sticking it out. AMD offered a few sort of sellout hits with the K6, Duron, and truly sort of peaked with the first dual-core Athlon X2 and later quad-core X4. They also brought 64-bit chips to the market with their AMD 64 instruction set, or sort of extension for x86, which is when, at least according to Passmark, AMD hit their highest ever desktop market share, actually surpassing Intel for at least a very short while. Then, of course, things went downhill. Their Phenom line of chips, including the infamous Phenom 2 X3, which, at least for the early units, could be unlocked to run as the full-fat X6 6-core instead, and worse, the FX line really hit AMD hard. Their core design, especially for the FX chips, was pretty limiting. Splitting one floating point unit across two integer units and still calling that two cores meant that they didn't perform overly well, especially for 8-core parts, and combine that with their foundries just drowning in money, they opted to do the unthinkable: sell off their foundries. AMD spun out GlobalFoundries in 2009, although AMD almost signed their death certificate with it by signing an exclusivity contract that locked them in to use GlobalFoundries for a number of years, requiring AMD to order wafers from GlobalFoundries at a set amount and price. That was wholly necessary to get any amount of value for the foundry business, but it brought them to their knees. I have a feeling that this might be a little prophetic for Intel. That level of stagnation was only emphasized by the finance bros at the helm squeezing every drop of value out of us, their customers. Everything from locking basic system settings like RAM speed to high-end unlocked CPU SKUs and motherboards, to changing socket every other CPU generation to force you to buy a new motherboard, and so much more, including even just steadily increasing CPU prices without much to show for it. The worst stuff, though, was all behind the scenes. In 2009, the EU fined Intel a whopping 1.06 billion euros for anti-competitive practices. Just to emphasize how evil this was, they were effectively paying distributors to stop them from buying AMD CPUs. In other words, paying for exclusivity. That included system integrators, people like Dell or HP for example, to only use Intel CPUs. And yeah, paying major retailers to only buy Intel CPUs or sell Intel systems. AMD literally tried to give 1 million free CPUs to a large computer manufacturer, but thanks to those Intel rebates, accepting those free CPUs would have cost the maker millions. So they could only accept 160,000 of those, again, free CPUs. They even made a major PC maker delay their first AMD-based business desktop by 6 months so that Intel could get out ahead. Yikes. Oh, and that isn't all. The FTC also fined Intel $1.25 billion just a year after the EU's billion-euro fine for the same sort of tactics in the USA. But there's more too. Intel changed compiler settings to favor their own CPUs without telling developers to hurt AMD's benchmark performance, and paid and coerced software and hardware vendors to either not, or at least very limitedly, support their AMD for support CPUs like AMD CPUs. Like, really, Intel? You were already winning, bro. Chill. And then there's the process node problem. From 2015 to 2021, that's Skylake to Rocket Lake, or 6th to 11th generation, Intel was stuck on their 14nm process node. For those counting, that's Skylake, Kaby Lake, Coffee Lake, Comet Lake, and Rocket Lake, or 5 generations of CPUs, all on essentially the same process node. Why? Well, there are a whole bunch of reasons. The 14nm node was delayed at first, and because Intel didn't have leapfrogging development teams, as in one team working on the current node and one team working simultaneously on the next one, that caused 10nm to be delayed. They shot for a frankly ridiculous transistor density target at first, which meant that yields were reportedly sub 1%. As in, for every 100 chips they made, maybe one of them would actually work, which meant that the only 10nm chip that they produced at first was a tiny dual core, which drew more power than a 22nm chip, and the IGP was broken. That's how bad it was. Intel iterated the design for Ice Lake, but the process node was still not good enough for desktop, so all they could manage was their almost unchallenged laptop SKUs. Tiger Lake brought another iteration with 10nm Superfin, which again, wasn't good enough for desktop. Finally, in 2021, they launched 10nm enhanced superfin, later renamed to Intel 7 to align with TSMC's N7 node, which has similar densities with Alder Lake. Although it's worth noting that only that and Raptor Lake, which is 13th and 14th gen, used that node. For context, TSMC's N7 node was first producing customer chips in 2018, Apple's A12 Bionic, with AMD using it in 2019, 2 years earlier than Intel's first mainstream 10nm/7nm node. Intel's next node, now called Intel 4, clearly struggled to hit yields too. Its only use was in the mobile-only Meteor Lake chips, as the following desktop and mobile chips, that being Arrow and Lunar Lake, opted to use TSMC's N3B node for the cores at least. The next node, at least skipping over Intel 3, as that just doesn't seem to exist, 18A is what the last CEO, Pat Gelsinger, kinda bet the whole company on, and it's yet currently unclear whether or not Intel's next generation of at least desktop chips are going to be using it. Their mobile Panther Lake chips will, but they might be outsourcing the desktop stuff to TSMC again. Intel is, at least currently, spending between $14 and $18 billion a year on R&D alone, and it sure looks like they're struggling to find any results from that. While they claim 18A is 25% faster or 36% more efficient than Intel 3, that's a bit of a poor comparison since Intel has never released a single Intel 3 based chip. Intel has invested heavily in improving their foundries, including buying the entire year's worth of production of ASML's high-NA EUV machines, video about those in the cards above, which are a cool $400 million each, although it's very unlikely that those will be used for 18A, more likely for the upcoming 14A process node instead. Although a part of that spend is their new IDM business. Until recently, Intel's fabs were used exclusively by Intel. They did actually open their foundries between 2013 and 2018, but this is IDM 2.0. This approach was a bid to attract customers to get their chips made by Intel rather than by TSMC. Unfortunately for Intel, they don't seem to have landed many or potentially any customers, and importantly for their flagship nodes, they really require hero customers to justify the R&D spend, and if they themselves aren't even using it, why would anyone else? Confidence in their foundries was most definitely shaken when the Rustgate scandal set the internet ablaze. Throughout 2024, Intel's 13th and 14th generation of CPUs started experiencing massive failure rates, orders of magnitude higher than usual, especially on the higher end parts. While initially there was a lot of speculation, and Intel only fueled those fires in an effort to not point the finger at themselves, it turned out that there was two very much Intel problems that were the cause. A microcode issue making the CPUs request the motherboard to burn them alive, and oxidization of the vias inside the CPU. The former was eventually fixed, but the latter could only be fixed with a replacement CPU, and Intel's handling of the event was quite a sight to behold. See, when AMD's Ryzen 7000 series chips started melting in their sockets, regardless of the blame, AMD immediately offered brand new CPUs and motherboards and started investigating the issue and addressed the root cause as quickly as they could. Intel, on the other hand, blamed motherboard vendors and users, only to then admit that they knew about the oxidization issue in, quote, late 2022, but still shipped the damn CPUs anyway. They said that they'd extend the owner's warranties, but then denied a whole bunch of RMA requests for dead chips. It wasn't a good look for the brand or their manufacturing capabilities. Okay, just because it's pretty funny, I'll include the little bit of fraudulent misrepresentation they did at Computex in 2018. At the time, AMD was kind of starting to cook with Ryzen and, importantly for this story, their Threadripper line of chips. They'd already launched the first gen Threadripper with up to 16 cores, but the second gen chips were coming, and AMD was promising a 250 watt 32 core chip, all for $1,800. So Intel, clearly in a panic and needing something to show off at Computex, decided to haul out one of their the highest core count server Xeon chip they had, claimed that it would be coming later this year as a desktop chip, and then they ran benchmarks on stage showing the chip running at 5 GHz and wolfing down Cinebench multi-thread. Pretty cool, right? Well, that's the thing, and that's what they didn't say. In fact, what they hid under the desk was that to run that chip at 5 GHz and get that level of performance, you needed close to 1,000 watts and a 1,700 watt water chiller. That's like doing a naturally aspirated drag race, but hiding the nitrous bottle under your boot floor. In the present then, Intel looks to be in trouble. What's somewhat worrying is that their new CEO, Lip-Bu seems to be trying to make some aggressive changes to, and I quote, pull off a comeback that will be studied in business schools for generations to come. And yet, is maybe throwing the baby out with the bathwater a bit? He's sacking another 25,000 employees by the end of the year, after Intel's already cut up to, I think, 15,000 of its staff, and a good couple thousand of those are this year alone already. And importantly, he's kind of pulling back on the Foundry business, stating, we will build what our customers need when they need it, and making it clear that going forward, our investment in Intel 14A will be based on confirmed customer commitments. There are no more blank checks. That seems a bit circular, as customers will not invest in designing for a process node that does not exist and that can't exist without their commitment. Chicken, meat, egg. To me, it seems that Intel has actually two major challenge areas: the products and the Foundry. The Foundry is floundering, with its success hinging on 18A and 18A-P, but the product front is another kettle of fish. Intel is losing market share in the server space. It seems to be the biggest loser in the AI race, and in the consumer space, the Core Ultra 200 series is frankly a disaster. According to MindFactory's sales data, in week 28 of 2025, they sold just 140 Intel CPUs, compared to 1,725 AMD chips. And the average selling price was nearly €60 higher for AMD too. Even worse, of those 140 CPUs sold, only 20 were the Core Ultra series chips, with the vast majority being the older LGA 1700 based chips. Yikes. With AMD's strong success from their X3D chips offering ridiculous performance benefits, Intel is really going to struggle to keep up, at least in the gaming space. AMD has been remarkably flexible, even in the server space, but by contrast, Intel has been rigid. That'll likely have to change, and pretty quickly, for them to regain their footing. To be clear, while Intel has done some genuinely heinous stuff over the years, we as consumers need them to survive. We need competition. Just look at AMD. Their underdog state is what led them here, and the lack of competition is why Intel is here too. They both need to be making competitive products for us consumers to see the benefits, which is better products at lower prices. Competition is what keeps them all in check, and that's something we sorely need. So I hope that Intel can turn it around, be that by selling off their Foundry arm, although I fear that that might actually be a dangerous act too, or by pulling through on 18A and 14A. Only time will tell on that though. So there you have it, at least a brief look at Intel's past, present, and potentially their future. I'd love to hear what you think in the comments down below of Intel's past antics and their current state, and what the future might hold for them, maybe what you would recommend. Let me know in the comments down below. If you want to see more of these essay style videos, you can hit the subscribe button and let me know in the comments down below. There is also a bunch already on the channel, including Intel and AMD's early history, stuff about the high NA EUV machines, and a load of other stuff too. The playlist for those will be on the end cards if you want to check them out. Otherwise, that's kind of it. Thank you very much for watching. If you want to support the channel, there are a load of links in the description, including to my own hardware, the open source response time and latency testing tools. And otherwise, yeah, thanks for watching. Hope you enjoyed it, and I'll see you all in the next video.